Hey everyone, happy Monday. Today we're going to talk a little bit about equations with variables on both sides. Last week we did some and talked about getting rid of a variable, moving them all to the same side. But there's one more step that we need to talk about, and that's special cases. So there's two special cases that you could have when you have variables on both sides. So let's say that we have something like 2 times 4x plus 7. And over here we have 8 times 5 plus x minus 10. So you can't really tell a difference between this problem and the other problems. They look pretty similar. So I'm going to go ahead and use those same steps that we talked about to solve these. So first I'm going to distribute on this side. 2 times 4x is 8x. 2 times 7 is 14. Over here we're going to do the same thing. 8 times 5 is 40. 8 times x is 8x. And we still have this minus 10 hanging out on the outside, which means that we have some like terms over here. We can combine 40, 40, and negative 10 to give me 30. We still have 8x, and there we go. Now you might be able to tell what the problem is going to be. Last week we talked about it doesn't matter which variable we get rid of. Well, if you notice this time they're both 8s. So regardless of which one we get rid of, if I subtract 8x, the same thing is going to happen, and that is that they are going to cancel on both sides. So, what do we do when that happens? Well, there's two possibilities, and that's why we have two special cases. We always look at what we have left. In this case, we have 14 equals 30. Now, I know you guys are smart out there. So, easiest question of the year. Does 14 equal 30? Hopefully, you would say no. It definitely does not. If we're left with a false statement, right? 14 does not equal 30. This is what's called a no solution. Basically what that means is that there is no number that exists in the real number system that I could plug in here for x that would make this statement true on both sides. So this is a no solution. In fact, sometimes we use this little symbol for like the empty set. It's like a 0 with a line from the top right to the bottom left. That stands for no solution. So I don't care once you get here if you want to write no solution or if you want to just use the symbol. You guys can see that okay? Yeah. But that is one special case. We could have the case where we don't have an answer at all. There's nothing that works here. I'm going to flip it. I'm not sure how good the red marker. I'm going to try the black marker and see if that one shows up a little better. So our other special case is going to look very similar. Let's say we had something like 3 times 4x plus 5 equals 6 times 2x plus 1 and plus 9 on the outside. Let's say we have one like this. Oh yeah, that looks a lot better with the black marker. Hopefully you guys can see it fine. As always, let me know if you guys are having problems seeing anything or hearing or anything like that. So we're going to do the same steps. Again, we're going to distribute. 3 times 4x is 12x. 3 times 5 is 15. Over here, 6 times 2x is 12x. And 6 times 1 is 6. We have some like terms again on the right side, so we can add 6 and 9. That's going to give me 15. And you probably can tell right from here what's going on. But if you wanted to keep going with your steps, get rid of a variable, you notice that again, they're going to cancel on both sides. They're the exact same thing. But this time we're left with the true statement. 15 does equal 15. So this is what they'd call the identity solution, I guess. It's the same thing on both sides. So what I like to say here, and this is what you're going to use in later on, is this is all real numbers or infinite solutions. I don't care which one of those you write. It's the same thing. So it's kind of up to you. But if we're left with the same thing on both sides, basically what that means is that if you take any real number and plug it up here for x and up here for x, you're always going to get the same thing on both sides no matter what, because the sides are the same thing. So this is infinite solutions, or all real numbers, all numbers in the real number system. And like I said, it's called the identity, which just means it's the same on both sides. So those are our two special cases. That's kind of all I'm going to do for you today. Couple practice ones for homework, and then yeah, we'll keep getting into it this week. So remember, I'll be online today for office hours. If you guys have any questions for anything, let me know. Pop on there and ask if you're not getting anything. If there's stuff from last week that you have questions about, you want me to go over in person. Remember, that's your guys' platform. So definitely make sure you do that. Also, make sure that you are turning in your assignments by 10:45 the next day. Some of you are getting late points, and I'm going to be hard on you for that. That's your class period, 10:45, that you need to have your stuff turned in by, because that's the only time I really have during the day to put the grades in. So make sure you guys are getting that stuff done, and I will talk to you tomorrow. Have a good one.